Hi guys, this is a continuation of the Unit 10 Part 2 study guide, and we're going to take a look now at question number 6. Okay? Now, question number 6 is a problem that involves interior angles of a circle. Let me clarify what I mean by that, okay? When I say interior angles, I just mean that the angle we're looking at here is inside, as opposed to being outside the circle. Okay? Now, this problem is a little bit different than the other ones that we've seen before, just because instead of subtracting the arcs, this is the only problem where you're going to have to add the arcs instead. Okay? So if you see a problem like this, where the angle is inside the circle, not outside, this is where you have to add the arcs. Now let's review the theorem first. It takes 2 of the angle inside to make the sum of the arcs. Let me say that again. It takes 2 of the angle inside to make the arcs added up. So if I actually want to write that in equation form, here's what I'd get. 2 times 8x plus 15 equals 15x minus 10 plus 50. From here, what we do is we use our Algebra 1 skills from last year. On the left-hand side, we're going to use the distributive property. Okay. From here, it's a multi-step equation with variables on both sides. Subtract 15x, and then subtract 30, and I believe that I get x equals 10. Now, of course, that's not what they asked for. What did they ask for instead? They asked for the measure of arc RS, right? So what I do, this right here is RS, I would just take the 10 and I would plug it in. So what's 10 times 15? 150. 150 minus 10, 140 degrees. Okay? Regular, I think it's going to be a little easier on yours, all right? Like maybe just a little bit less algebra. Honors, though, this is fair game. Okay, and this is actually very similar to something you may have seen on the EOC, if of course we had an EOC. Okay, now let's take a look at question number 7. By the way, if you heard that barking in the background, that was probably my dog, Coco, barking at the mailman, or maybe the garbage truck, or I don't know what, but she doesn't really need much of a reason to bark. Okay, next up, question 7. She's just provided me with a soundtrack. Alright, so this is 3x plus 12. This is 12x plus 3. And this is 45. Alright, guys. So the thing with this question, or what makes it different from the previous one, look at where our angle is. Our angle is outside. Let me say that one more time. In contrast to the previous problem, the angle is outside. What that means is that it's going to take 2 of this angle, just like it did with the other one, but it's going to take 2 of them to make the difference of the arcs. In other words, it's the same problem, but instead of adding the arcs, you subtract them. Okay? So, let's set this up. It takes 2 of this angle outside, so 2 3x plus 12s, to equal the difference of the arcs. From here, we're back to Algebra 1, Chapter 1. Distributive property. So I'm going to get 6x plus 24. Combined like terms, right? Careful with your integers here, a few of you, right? You know who you are. Minus 42. Then, inverse operations. Subtract 6x from both sides. Add 42 to both sides, and I get, what is it, 6? Oh, yeah. And that means that x equals 11. Of course, was that what they were asking for? No, because that would make life way too easy. Instead, in the problem, they asked us for angle QRS, which is right here. So I would just take that 11, mosey on over. 3 times 11 is 33, and 33 plus, I gotta do my addition here, oh my gosh. 33 plus 12 is 45. Okay? So, again, these problems are not terribly difficult once you set up the equation. The hard part for a lot of you guys is just going to be setting that equation up, all right? So, you know, just bear that in mind, okay? If the angle is inside, then you add the arcs. If the angle is outside, you subtract the arcs. All right, question number 8, one of my favorites. I mean, I know I say that all the time. I have many favorite problems, but still. I like this one because it's a quadratic. All right. Let's take a look. There we go. There we go. 7, 9. Okay. So the big thing here, guys, right, is to remember that when we are looking at the lengths of secants and tangents, that's what we have here, the exterior times the whole thing is going to equal the exterior times the whole thing. So the important thing here is setting up the equation correctly. Let's look at the secant down here. The secant down here, the exterior is 7. What's the whole thing? Well, 7 plus 9. So I'm going to write that as 16. Again, where did I get the 16 from? The whole thing is 7 plus 9. Let's take a look at the other side. The exterior is 8x, right? And what's the whole thing? Well, 8x plus 6x, which is, oh my gosh, 14x, right? Okay, from here, remember, over here, x times x, that's going to have to give me x squared. So please, please, please don't forget about that, guys, okay? So let's do some math. 7 times 10, 70 plus, so what is that, 112? And that's going to equal, let's see, 80 plus 32. Is that also 112? Oh my gosh. So in order to get rid of a multiplied 112, I would simply divide both sides by 112. So I get 1 equals x squared, therefore x equals 1. All right? Now, that was really nice that that worked out that way, okay? But the big thing I will tell you guys to watch out for, make sure you don't forget to do the x times x equals x squared, okay? That's I know a couple of you guys came to me with questions on the homework. That was the biggest mistake by far that I saw, all right? So just, you know, bear that in mind. All right, question number 9. Question number 9 is what I like to call a product of the pieces problem. Let me say that again. Question number 9 is what I like to call a product of the pieces problem. In other words, if I multiply the pieces of one chord, they're going to equal the product of the pieces of the other chord. So let's take a look. This is 4x plus 2 and 8, and this is 9 and 4x. So think about what I just said. The product of the pieces. Okay, so this chord right here, the one that goes kind of horizontally, or I guess it's kind of diagonally, but I just drew it wrong. Oops. So I'm going to do piece times piece. So I'm going to write that as 8 times 4x plus 2. What do you guys think that the equation would be for the other chord? Well, let's take a look. 9 times 4x. From there, it's actually really an algebra problem, right? Subtract 32x from both sides, and I get 16 equals 4x. Obviously, x equals 4. Okay? Again, this is a relatively easy problem, okay? The main thing, just don't mess up your distribution, because if you end up with like some funky decimal, that's probably what happened. Okay? Anyway, let's move on. Question number 10. By the way, question number 10, guys, is fair game for both honors and for regular. Okay? So bear that in mind. Unless I specifically designated a question as honors only, regular, you guys are responsible for it. Okay? X, 3, 5. Okay, so this problem is very similar to, which other one? Very, very similar to question number 8, all right? we're still going to be using exterior times whole equals exterior times whole. The only difference this time is instead of being a quadratic, it's going to be a linear equation that we have to solve using our regular old Algebra 1 inverse operations. So let's take a look. For this secant right here, exterior is 3, and the whole thing is 8. So I'm going to have 3 times 8. Again, where did I get 8 from? 5 and 3 make 8 when I add them up. On the other side, I'm going to have my exterior, which is 4, and what's the whole thing but 4 plus, oh, is it getting cut off? There you go. 4 plus x. So let me do some math here. 24 equals 16 plus 4x. Subtract 16 from both sides to get 8 equals 4x, and thus x equals 2. All right. Again, you know, the equations themselves are not hard. The only thing that's going to kind of pose a little bit of an issue for some of you is setting the original equation up. So if you can just remember exterior times whole equals exterior times whole, that'll make your lives a lot easier. All right? And this is the last one. Oh my goodness. Number 11. This one is technically just the Pythagorean theorem problem, but I'll show the whole thing out anyway. Regular. For you guys, this is going to be tested a little bit more conceptually. All right, so I'm just going to make sure that everybody's good with the vocabulary that I expect you to be familiar with. Okay, so a couple things here, right? They tell us in the problem to assume that this right here is tangent to the circle. Okay, and there's a reason for that. If a line is tangent to a circle, at the point of tangency, what is this angle going to be right here? Well, think about how many degrees does it look like? It looks like it's 90, and it actually is 90. And the reason for that, using formal language, is that the tangent line is perpendicular to the radius. Okay, let me say that again. If a line is tangent to a circle, then it is perpendicular to the radius, meaning it forms a 90-degree angle at the point of tangency. Okay, regular, please, please, please make sure that you know that, because guess what? It's on the test. Okay, anyway, this problem turns then into a Pythagorean theorem problem. If this is 1.5, because it's a radius, then this right here is also 1.5. So in order to be able to find this unknown side, all I have to do is use the Pythagorean theorem. Just to make things a little bit easier, okay, I personally prefer to, actually, you know what? I take that back. We're just going to leave them as decimals for you, all right? So this hypotenuse is actually 2.5 because it's the combination of those. So I'm going to do 1.5 squared. I'm going to call this unknown leg b plus b squared equals 2.5 squared. So far, this is just unit 1 from geometry, right? When I do the math here, I get 2.25 plus b squared equals 6.25. If you're wondering how I did that without a calculator, well, if you guys memorize your perfect squares, right, that is just really a matter of moving the decimals. Subtract 2.25 from both sides, and I get that b squared equals 4. Take the square root, and thus b equals 2. Okay? Now, let's talk about strategy for this exam, okay? Honors. My biggest suggestion for you is to make sure that you go back and you review the completing the square problems, okay, to find the center and radius of a circle. There will be 2 questions on the test worth a total of 6 points. They are not multiple choice. They are not drop downs. You must know how to do them, okay? I did put some extra practice for you guys online. Okay, it's called like optional extra practice. It's under modules from like this week, okay, week 6. So I really would encourage you guys to make sure that you remember that. Regular. What I would really suggest for you guys in particular is getting the different theorems straight, okay? For example, if I have intersecting chords, right, and I call this A and B and this C and D, what you want to remember is that the product of the pieces equals the product of the pieces. So for example, A times B equals C times D. Okay? Similarly, they could ask that question in a slightly different way. Let's say that they gave you a circle instead, and they gave you guys this secant. So A, B, C, and D. Well, in that case, the exterior times the whole would equal the exterior times the whole. So I could actually write this using these kind of like constants right here, or variables if you want to think of them that way, as A times A plus B equals C times C plus D. So there will be a fair number of what I call freebies, right? Where if you know the concept, you're gonna be pretty happy with your test result, all right? But again, you need to make sure that you recognize which equations apply to which problems. All right, hope you guys enjoyed. Any questions, you're more than welcome to come see me during Teams meetings or send me a Canvas message. Have a great day. Don't downvote my video. Thanks so much. Bye-bye.